In this lesson, we're going to discuss how to do algebra with functions. First, we need to understand some notation. If we have two functions, say f of x equals 4x plus 1 and g of x equals x squared, we can show we want to apply basic arithmetic to them like this. F plus g means to add function f and g together, like this. In purple, you will see I have the function f 4x plus 1 plus the g of x function as x squared. If I could simplify these, then I would continue to simplify. In this case, I don't have anything I can simplify. So let's take those two functions again and talk about some other notation. F minus g means to subtract function g from f, like this. 4x plus 1 is function f minus function g, which is x squared. 2f, or 2f of x, means to multiply the function by 2. So 2f of x, I would take 2 times parenthesis 4x plus 1. Last step would be to simplify anything you can. In this case, it becomes 8x plus 2. Let's take those two functions one more time. F over g means divide f by g. It looks like this. 4x plus 1 over x squared. Again, if we could simplify and reduce, we would be expected to. Let's try some more examples. Here's a couple of sample problems. Our functions are going to be f of x is equal to 3x minus 2, and g of x is equal to x squared plus 2x plus 5. In the first example, it is asking us to evaluate f of 0 minus g of 1. So I'm going to go ahead and plug in 0 into every location of x in the f of x function. So I tend to write it out like this. Here's the f function of 3x minus 2. I will put a parenthesis wherever I see an x. So this 0 is telling me to plug 0 in for x, so I put it inside the parenthesis. The next thing I'm going to do is minus g of 1. Now the g function, you can see, has 3 terms. So I'm going to need to put parentheses here to remind myself that I need to distribute the minus when I'm finishing. So again, I will put parentheses where all the x's are, so that's x squared plus 2 times x plus 5. Again, g of 1, so I'm going to put a 1 in for each of those parentheses. Now I need to simplify my numbers. In this case, since this is all numbers, I'm going to go ahead and complete the g of x together. The f, 3 times 0 being 0, 0 minus 2 is negative 2. The second parenthesis here, we have 1 squared, which is 1, plus 2 times 1, which is 2, so 1 plus 2 is 3, and 3 plus 5 is 8. So we have negative 2 minus 8. So our final answer for this particular example is negative 10. Let's evaluate 5 g of x. The 5 means to multiply our g of x function. So since there's just an x in the x-coordinate, I literally am going to just write down the g of x function. And I'm going to be multiplying that by 5. So I will go through and multiply, and that will get me 5x squared plus 10x plus 25. Nothing else to simplify. That would be my final answer. Let's try some other sample problems. Again, here are my two functions as before. The first example is g of x minus f of negative 2. So g of x, I'm going to replace first with x squared plus 2x plus 5 minus f of negative 2. So I'm going to take the f of x, which is 3x minus 2, and replace the x with negative 2. And now I go and start simplifying. So this set here is all numbers. So we have 3 times negative 2, which is negative 6. Negative 6 minus 2 is negative 8. So we now have x squared plus 2x plus 5 minus negative 8, so plus 8. There is something I can simplify, so my final answer will be x squared plus 2x plus 13. Let's evaluate f of a minus 2. So now I've got an expression in the argument location, but I'm still going to do the same thing. I'm going to take my f of x, I'm going to write it down, and leave a parenthesis everywhere I see an x. So whatever is in this parenthesis next to my function f, I'm going to write that in the parentheses where the x was. Now I just have to go through and see if there's anything to simplify. In this case, I can multiply 3 times a minus 2, so 3a minus 6 minus 2. I keep simplifying, 3a minus 8, and that's where I stop. Our last example on this page is g of negative b. So what I'm going to do now is I'm literally going to take the g of x, put parentheses for each x, and then I'm going to replace the x with negative b, which will look like this. Here is my x squared plus 2 times x plus 5. So the argument here, negative b, replaces every location of x. Now here I have negative b squared, so that becomes positive b squared plus, and that's also negative b, so plus 2 times negative b, or minus 2b, plus 5. So basically b squared minus 2b plus 5. And that's my final answer. Now you try. Here are two functions, f of x and g of x. I want you to first evaluate g of 5, then evaluate f of x minus h, and then evaluate f of a plus 1 minus g of a. Pause the video, complete these 3 problems. When you are completed, restart the video, and look along with my answers and see how you did. Okay, let's see how you did. We'll start with g of 5. So the g is identifying that I'm going to use this function here. So again, I write down my function with parentheses wherever I see the x as a way to remind me until I get used to it where I'm going to plug in the g of 5. So 5 goes in here for x, 5 goes in here for x, and I'm going to simplify. 5 times 5 is 25. 2 times 5 is 10, plus 5. So my final answer, 25 plus 10, 35 plus 5 is 40. Anytime I have just a number inside the parentheses for the function, that means I should end up with just a number for the answer. Let's try evaluate f of x minus h. So now I'm working with f of x, which is only x squared, but still I'm going to put my parenthesis down to show that whatever I do, I'm going to square it. So I take what's in the parentheses here and I replace the x with that. So now I have x minus h squared. My job is to simplify. So again, if you remember, this is x minus h times itself. So x squared minus 2xh plus h squared. And that's as simple as I can go, so that is where I'm going to stop. Our last example, f of a plus 1 minus g of a. So again, let's start with f of a plus 1. So x squared minus g of a, so the g function, something squared, plus 2 times that same something, plus 5. So for f, I'm replacing it with a plus 1. For g, I'm replacing it simply with a. So now I do need to go through and simplify. I have a plus 1 squared, so I need to FOIL that out. A squared plus 2a plus 1 minus, now these are all variables, so I'm now going to have to distribute my minus sign. So this becomes minus a squared minus 2a minus 5. A squared minus a squared cancels. 2a minus 2a cancels. I'm left with 1 minus 5. So for this particular example, I actually ended up with a number of -4.